But it gives me great pleasure now to introduce the sponsor for our theatre today. I'd like to hand you over to David Girdler, who is the Chief Executive Officer at McCulloch Group.
Thank you. Right. Good afternoon, everyone. As I said, I'm the CEO of McCulloch Group. I'm here to talk about our journey to net zero emissions, and it starts really with a fundamental, and that's change. So I thought I'd look in the dictionary, and change is all about positive improvement, evolution, etc. But those of us who are a wee bit longer in the tooth probably haven't always felt that change is associated with the positive side of things. So to kick off with, what I thought I'd ask is a quick show of hands of who feels that the diesel or petrol is the solution for propelling kit going forward? Anyone? Electric? Hydrogen? Sodium? Anything else? Well, we've already gone with electric anyway, so whether it's the right solution or not, we'll find out in the fullness of time. But what you've demonstrated really is the appetite for change within the industry. Now, we started that process, which I'll come to with a partner, Unipart Rail. But first of all, I'll just give you a quick few seconds about the kit that we use, which is our track rail transposer, the TRT. For those of you that aren't familiar with it, Billy McCulloch is an inventor. He founded the company with his brother Danny, and the TRT was the first bit of kit they introduced, and it's very different from everything that you'll probably see around this area, because unlike the kit externally, which is generally Civil's kit that's been adapted to work on the rail network, all of our kit is bespoke and designed by rail people, for rail people to work on the network. And that's a huge difference, and the TRT in particular, because of that, is very efficient, and that makes it the ideal donor to look to convert to a fully electric system. Which brings me on to the funding side of it. So our partner, Unipart Rail, who I can see are represented here, they've been really good to work with, and they applied for a grant from the Department for Transport, Innovate UK funding for first-of-a-kind projects in 2020. And through that, they developed a team comprised of Unipart Rail, ourselves, Hypervat, Williams Advanced Engineering, Advanced Electrical Machines, and SR Technology, along with a 6-month program to develop the TRT-E. Now, the basis of that really was taking a TRT and, unsurprisingly, taking out the internal combustion engine and replacing it with a motor and a battery pack, which sounds simple, but it isn't quite that simple. Over a period of time, that evolved. That was readied within 6 months, as I said, and that was a year ago. And in the time since then, we've been spending understanding a better idea of the duty cycle in real-world situations to give us a better understanding of what the demands on the battery pack are. That directly led to discussions about the existing power unit. Unfortunately, the cost of innovation and progress meant that there was a 7-figure sum attached to converting that into a production-approved method. So that was really not economically viable, and instead we, I can't see Ian Morgan, who's our head of engineering, he's probably around somewhere, but he's been instrumental in going around and securing an alternative battery source. Now, I'm sure everyone's seen in the papers about the concerns over the economic impact and the environmental impact and the human impact of sourcing the materials that are required for battery power units to be manufactured. And what we've done is we've gone and we found potentially a system that works, which utilizes life-expired automotive battery packs, such as a Nissan Leaf, etc., and they can be repurposed, because when it can't propel a Nissan Leaf to 70 miles per hour, if they do 70 miles per hour, for a period of time, it's still able to be used for our kit because of the efficiency, because it lifts from within its footprint, as I said earlier. So that's been ongoing, and we've also found a drive motor company that doesn't use any rare earth materials and any metals in it, which is it's quite good to have that green-on-green type credential. But all the signs are that it's a really effective piece of kit. It's just in the final stages of pre-production, and it's going to be manufactured ready for September. But what it really leads to is probably a more interesting industry challenge, and that is, it's all very well us and others going and developing a lot of green technology, but what happens when you get onto the network? You know, where are the charging points on the network? Where's that infrastructure? Because as soon as you leave the infrastructure to go and charge your battery, take your vehicle away, whatever, you're hugely compromising your carbon footprint and probably negating any of the benefits that you've done in delivering a fully electric, emission-free system. So I guess the question is, are we on the right path? And we'll only know in the fullness of time. But one thing's for sure, really, I think if there's enough momentum, I think, for these things to change, that if a change is required, it will happen. And we've already said, I think the internal combustion engine's days are numbered. But what the final solution is, none of us know. But I think having that flexibility and adaptability will be key to finding a good long-term solution. So if you get the chance, do come and see the TRTE, which is on our stand, which is S29. S29, so it'd be great to see you there. And if you've got any questions, I wish Ian was here because he's 10 times more technically knowledgeable than I am. But apart from that, thanks for your time.
Thanks. Wonderful. Thank you so much, David. Absolutely fascinating stuff. And I am going to plug as well, TRTE was funded by us through the First of a Kind programme at Innovate UK KTN. So thank you very much for bringing that one up. We do love a good plug. So now we're going to jump straight into a joint presentation around new technologies, again, to improve the sustainability of rail. We're going to hear from Martin Frobisher, Group Safety and Engineering Director at Network Rail, and then from Helen Simpson, Innovation and Projects Director at Porterbrook. So straight over to you.
Thanks, Daisy. Right. I want to start with this slide, which is a picture that we took during the COP26 conference last year. It shows the Forth Bridge in the background, which is an amazing piece of railway history. And look, if you look down at the front, at the side, you will see the Viva Rail battery train that we brought to the conference. And that's an electric train. It's the Tesla equivalent in the railway world. And that is the first time in the history of the railway that a train crossed the Forth Bridge without using fossil fuel. So it's only a small photo that we took last year, but I think that's a real milestone in railway history. And what I'd like to talk about today is the environmental strategy for Network Rail, the things that we're doing to improve the environmental credentials of the railway. And it's a joint presentation with Helen from Porterbrook, who will give us a bit more detail about the development of the hydrogen train that was also brought to COP, and that was an amazing success at the UN conference. So that's this presentation. Now, there is so much in the field of environment. You know, there's about 1 million different things that you could talk about 1 million different things that you could work on. So the first thing we did at Network Rail was to really try and figure out what are our top priorities, what are the things that we want to focus on. And we decided to home in 4 key areas. First of all, reducing emissions, and ultimately getting to a net zero railway. Now, reducing emissions is partly about zero carbon, but it's also about things like air quality in stations, in city centres. You know, we're seeing massive change where city mayors are saying, don't bring diesel cars into this city. And it's not long before they will be saying, don't bring diesel trains into this city. So we've got to have an agenda about reducing emissions and getting to zero emission trains. The next thing we've got to focus on is recycling waste. And I don't mean just coffee cups, I mean the really big things, the things that cause all the embedded carbon in the railway. We then got to look at how we reduce the impact of climate change. Because, of course, there's 2 things going on. There's the damage that we cause to the environment, and then, of course, the environment bites back, and it affects railway operations. How do we make the railway more resilient to the storms and the flooding and the heat of the future? So that's one of our priorities. And finally, our 4th big priority is biodiversity. We're one of the biggest landowners in the country. We own thousands of miles of railway line side. It's inhabited by all kinds of rare and precious creatures. How do we make sure that we manage the biodiversity properly on that massive land estate? So those are our priorities for our environment strategy. So let me start with reducing emissions. Now, I think it's clear that the best type of railway is an electric railway. Overhead line catenary, you just can't beat it environmentally. Electricity generated by wind power, solar panel, or some other renewable means, transmitted at high voltage, put into the train by catenary electrification. Environmentally, you can't beat it. But catenary electrification is hugely expensive. If you think about the cost of electrification schemes, people don't just, when you talk about electrification schemes, people think about wires. But of course, it's making space for the wires. It's rebuilding all the bridges, working on the tunnels, massive amounts of civil engineering. And these projects are expensive. So you can't beat catenary electrification for its environmental credentials, but it costs an awful lot of money. One of our priorities is to reduce the cost of electrification. So our research program is looking at how we reduce electrification clearances, how we use modern insulation materials to reduce the gap between the wires and the structures. And we're making great progress. How we reduce the size of the foundations. And we're spending lots of money on research. We've got a lot of UK universities working on it. And we're working to find lots of solutions that bring down the cost of catenary electrification. But it's always going to be expensive. And we're also looking at what are the other modes of traction power that we can use on secondary lines, on rural lines, as alternatives to overhead line. And battery is one of those technologies. As I said at the start, we brought the battery train to COP26, and we're seeing massive advances in battery technology. The Viva Rail train is now 60 miles an hour, 60-mile range. That's starting to look like a credible option for some of the branch lines. We've got hydrogen as an option, and Helen will talk in more detail about the Hydroflex train. But that's achieving a 300-mile range at 100 miles an hour, and that's even more practical for many of our duty cycles. There's lots of other possible options. You can burn hydrogen in an engine. You can put it into a gas turbine. There are lots of different technology options which are possibilities. One that we're really interested in is ammonia. Now, ammonia, if you think about the chemistry, ammonia is 3 hydrogen atoms on a nitrogen atom. Diesel is 4 hydrogens on a carbon atom. The fuel density of ammonia is not vastly different to diesel. It's toxic, it's got lots of issues with it, but it is a very portable fuel that is a credible alternative for diesel on the railway. And we've got some significant research projects ongoing, particularly with Birmingham University, who are looking at how we can modify engines to run on ammonia and possibly use that for rail freight. And that's a really exciting possibility for the future. So there's lots of research happening in a number of different areas, and I think it creates a few exciting possibilities. For recycling, we want to focus on the really big things. Now, there's been some great initiatives, recycling coffee cups in stations, and that raises awareness, and making sure that we recycle PPE, and again, that helps to raise awareness. But the things that make the biggest difference are steel, concrete, and ballast. That's where our carbon really goes. So we're looking, as we move to the future, at procurement strategies that improve the environmental credentials of steel, concrete, and ballast. That's where we're going to be focusing. So contracts for buying steel in the future are going to demand that that steel came from an electric arc furnace powered by renewable electricity rather than guzzling fossil fuel. In order to make an electric arc furnace work, we're going to have to recycle a lot of the rail that we've got at the moment. So put second-hand rail back into the furnace in order to create new steel with environmental credentials. Because it's very hard to make railway quality steel from scratch in an electric arc furnace. If you feed in lots of existing rail and recycle it, you're able to achieve the quality requirements much more effectively. So we're going to have to recycle the rail, use electric arc furnaces, and in doing so, we'll massively reduce the amount of carbon that gets embedded in the railway. Lots and lots on concrete. That's about creative design, reducing the amount of concrete we use, using composite materials for things like sleepers. Lots of possibilities for reducing embedded carbon with concrete. And ballast, recycling as much as we can. So there's lots of options for reducing the embedded carbon in the railway. As I said at the start, the climate really bites back. So we have a big piece of work looking at how do we cope with climate change. More storms, more rainfall, more wind. You know, we've started to see that already. You know, the terrible tragedy at Carmont, where passengers, colleagues on the railway were killed in the first tragic train crash in more than a decade. And that is the effect of climate change. So we're looking at how we can make the railway more resilient. Realistically, we cannot rebuild all the Victorian embankments. So we're going to be looking at using more technology, instrumenting, better weather forecasting, identifying when things are starting to fail, and making sure that we keep our passengers safe. So lots and lots of opportunities to use technology to make the railway safer during the storms and the flooding that we can expect in years to come. We've already made a good start. The convective alerting tool, that probably doesn't mean much to many people, but it's an amazing piece of technology that's looking at weather data on a much, much finer grid, being able to spot convective storms as they form before massive amounts of rain get dumped on the railway, spot it in real time. Then our control centres can control the speed of trains using radio alerts to slow things down just for a short period of time where we're seeing massive convective storms. And that's here today. It's an amazing bit of weather forecasting technology, but it is really changing the way that we operate the railway in real time. We've got what we're calling Project Otto, which is a clever alternative to the European train control system, using today's radio systems, today's data, and transmitting it out to trains in order to provide movement authority and the safety benefits of the European train control system. So again, some great British engineering that is allowing us to improve safety at reduced costs, and lots of intelligent infrastructure. But the final bit of technology that I really want to finish on, and one that I'm really, really proud of, is the work that we're doing to improve the biodiversity on the line side. You know, as I say, we're a massive landowner. We've got huge amounts of railway line side with all kinds of species. And how do you manage the biodiversity? We got a recommendation from the Varley report, from John Varley, that said, you need to make sure there is no net loss of biodiversity on the railway line side, and that in years to come, you need to improve the biodiversity. But how do you measure it? You know, there's thousands of miles out there. Do you keep sending people out to count critters? You know, it's really, really difficult to manage the biodiversity on the railway line side. And what we came up with was this amazing satellite technology. So a satellite overflies the whole of the UK, and then it breaks down the images into a 10-metre by 10-metre grid. And artificial intelligence determines what the habitat is in that 10-metre by 10-metre grid. And from that system, we've been able to produce some really great data about the habitat on the railway line side on a 10-metre by 10-metre grid. And what we're able to do then is to manage the habitat, to selectively improve it, and to make sure that we improve the biodiversity and improve the habitats on the land that we own and manage. So rather than counting critters, we're actually using a satellite to measure habitat. We're improving the habitats and thereby delivering more biodiversity. And I don't know about you, but I think that's really clever. I think it's making an amazing difference, and I think it's certainly improving our environmental credentials. So I'm going to stop there. I'm going to hand over to Helen, who's going to go into a bit more detail about the Porterbrook Hydroflex project, which was really the absolute star of the COP26 conference in Glasgow. Thank you.
Thanks, Martin. My name's Helen Simpson. I'm from Porterbrook, and I'm Innovation and Projects Director there. And as Martin said, we took our Hydroflex train, which is the UK's first hydrogen-powered train on the network, and we took it up to COP26. That was an amazing thing to do. It was a huge highlight for lots of people who've worked on the project, many of whom are here today. And we've actually got Hydroflex on site today, so if anybody would like to come and look at it, it's over by the Porterbrook marquee, a little bit further back, nearer the entrance. and you'd be very welcome to come and have a look round. I think that what I would say from Martin, it's a great introduction to Hydroflex there, but actually for us, if we want to really truly understand hydrogen trains, then we're going to need to build one, and we're going to need to showcase it and really demystify hydrogen technology and how that is done, the approvals, the safety, engaging with the supply chain to help us do that. If there's going to be lots of different suppliers needed to really make a transformation on that. So that's why Porterbrook took the decision, and I've been so lucky to be involved in this project and to have the support from our shareholders and great sponsors, Network Rail, to help us get the train to COP and really showcase it for the industry. So inside of Hydroflex, you need three fundamental things to run a hydrogen train. You need somewhere to store the hydrogen. So we have 36 high-pressure cylinder tanks, and we're capable of storing up to 277 kilograms of hydrogen on board. You need somewhere of converting the hydrogen and combining it with oxygen in a fuel cell to create electricity. We've got 4 of those rated at 125 kilowatts each. And the third thing you need is a traction battery. So Gemini, who are also here today, supplied our battery, and that gives a combined total power output. It works as a hybrid, both the fuel cell and the battery working together, to give about 800 kilowatts of power output. We've installed a complicated control system to manage that, and it blends both hydrogen and battery power. Fuel cells don't like ramping on and off very quickly. They need a slower speed of response. You have to treat them a bit gently. So the battery allows us to blend that and take those peak power demands and back off to low power demand as well. There's, of course, a lot of safety features involved in a hydrogen train, lots of systems and protection circuits, and if you come and have a look at it, I'll be happy to show you around all of those things. But we've got clearance fans, hydrogen detection, switch, automatic shutdown, fire systems. Everything is geared to protecting the circuit. So we manage the hydrogen very, very carefully on board. Our train retains its pantograph. It was a former 319 unit. We've retained the pantograph so we can operate in electric mode where the wires exist. And we get a range of about 300 miles off the electrified network. So it opens up quite a lot of possibilities for doing that. The cab layout is very, very similar to the 319 donor vehicle, and that was done deliberately so that we're not trying to make something that's very different to drive. It drives and feels the same as other trains on the network. And for COP26, we did something quite radical with the interior. So that's the boardroom that we installed on the train, and you'd come and have a look at that later. And we also created a social area and refurbished the whole of the inside for the passengers saloon. We had some really high-profile visitors. We were really lucky to show Prince Charles around. All the photos have me pointing at something. I don't know quite whether that's my skill in life. And we managed to run we ran it in with the pantograph up, but we had the whole of the hydro chamber open so that people could come and see it. And that's part of demystifying the technology and helping people learn and understand, helping our stakeholders to the industry really grasp that hydrogen trains are a possibility, and this is what one would look like. So if you want to see inside the hydro chamber, we're completing the last of our testing, and it's no hydrogen in today, but it soon will have, and all of the containment panel walls go up, and you won't be able to see it, so it's a real last opportunity to see it real live before all of that gets locked away. So that's a quick introduction to Hydroflex, a hugely exciting project I've been involved in. Very grateful for the support from Network Rail and Martin's team in particular, who absolutely helped us get to COP26. But thank you.
Hello again. Brilliant. Well, thank you so much. 3 really interesting presentations on obviously very interesting topics. And we are, again, going to be taking questions from the audience. So please do, think of what you'd like to ask with our very interesting speakers here today. But I'd like to kick off. I'd like to ask a question, to all 3 of you, really. So feel free to go one at a time up the line in whichever direction. So we know, obviously, the need to decarbonise. It's very obvious why we need to decarbonise. That's not really something that we need to discuss here today. But given that we've talked about, electrification being very expensive, it takes a lot of time, it's in some ways, very difficult. Not all of our network can be electrified by overheads, for example. I'd like to know what would the quickest wins be? So what are the things that you can do either in rail or in your organisations, very quickly for yourselves, for the people in this room? What could we do very quickly as a quick win in decarbonisation?
But from my perspective, it probably goes on from what I briefly covered, which is the reuse of batteries that are already in existence, which obviously doesn't do anything more negative to the planet, but also makes good use of recycling, something that's already had its full life cycle for another application. But other than that, our machinery is very different to yours, and it's a lot smaller, so it's quite simple for us. I think really it would just be replicating what we're doing currently with the TRTE to our other kit, because it's all fairly efficient, and it wouldn't take a huge amount to convert them. But it really depends on the appetite from the industry and from business.
Absolutely. And do you think that there is... do you think that appetite is there for converting the other kit in the way that you have done for the TRTE, or is that something that maybe the industry partners in the room today, is that something they need to take away?
Well, yeah, I think there's obviously a lot of interest in it, and there's a lot of words spoken, but I think it's really going to be how that translates into action. And as I said, if the infrastructure isn't there to support it, it's a little bit self-defeating to go through all that testing and rigmarole of a new source of energy, if we're then going to not support that actually in situ, because a lot of it, unfortunately, at the moment is really it's zero emissions at point of use, and that needs to be expanded to just zero emissions across the board.
Yeah,
through how the electricity is generated, obviously. So.
Yeah. Makes sense. Thank you so much.
So there's probably two ways of looking at that question, I think. So for the rolling stock side, there's an awful lot of embedded carbon in the trains that we have today. So making best use of what we've got and keeping trains refreshed and in service and keeping them going and making sure that they are as efficient as possible is definitely a practical step that we can do today. The second way of answering that question, I think, is about how we value, and this is a wider than rail question, about how we value the benefits from climate change or reduced emissions in terms of health benefits or benefits to society, and how we evaluate those in business cases, which would then lead to investments in the projects that you're talking about, I think.
Yeah. Absolutely. So come at it from all the angles rather than just specifically the decarb angle. So you've got to have the investment side and the support behind that too. Martin.
So I think the fastest thing we can do is about procurement. We use vast amounts of electricity on the railway, and making sure that our electricity procurement contracts are from renewable sources. So we're doing that right now, making sure that we get direct wire connections from renewable electricity generators, making sure that we buy electricity from renewable sources. That's probably the thing that will make the biggest short-term difference. But then I think there's also a whole load of things that we need to be doing now for the future. And I think getting better and faster at electrification projects. The teams up in Scotland have been doing really well at reducing the cost of electrification. They've got their unit rates down to almost half of what some of the other recent schemes are. To learn from that, to do electrification schemes better and faster. Because once we've built a track record of being able to build electrification schemes cheaply and cost effectively, that will win government investment to do more. Yeah. So I think there's a few things we need to be doing now. Good procurement for renewable electricity and demonstrating that we can do electrification schemes quickly.
Absolutely. Perfect. Thank you so much. I didn't expect procurement to come up in that context, but thank you. I hadn't thought of it that way. Are there any questions from our audience? We've got a gentleman over here. The mic's just on its way over.
Just a couple of questions, one for Martin and one for Helen. For Martin, on the electrification programs that you have, what for renewable energy specifically, the car industry is obviously working towards distributed energy because they have so many cars with batteries in them. Eventually, we will get to a stage where there's lots of trains that have batteries on them, and we can store the energy on the trains when the renewable energy is available. So when the wind is blowing, we will be able to use that energy and store it. How are you planning to have energy available from renewable energy at locations where you can charge the trains? Yep. Sorry.
Yeah. Okay. So I don't think it's just about battery trains. I think getting renewable electricity into the grid to drive catenary electrification is going to be the biggest part of a zero carbon railway. There will be, as you say, some charging of battery trains, but I think that's probably more on the secondary and rural lines. Again, that's coming off the grid and renewable electricity. But then, of course, if the UK's got lots of offshore wind, when's the wind not blowing is one of the big challenges. So I think for the railway, a reliance on nuclear is a factor. You know, we have to have sources of zero carbon electricity that aren't just wind or solar. You know, the railway runs 24/7, so we do need a reliable source. And the other big opportunity, which I mentioned, is ammonia. So offshore wind generates electricity. You then hydrolyze the electricity to produce hydrogen and oxygen. The hydrogen is used to make ammonia, green ammonia, using the Haber-Bosch process. And then ammonia is a really good fuel, which you can burn in an internal combustion engine, just like we do today. So ammonia is potentially a really good way of storing renewable energy and using it whenever you want to use it. And what's really interesting, actually, is that converting engines to run on ammonia isn't that difficult. During the Second World War, they ran out of diesel in Brussels, and they ran the city's buses and trams on ammonia as much as 80 years ago. So converting diesel engines to run on ammonia is a fairly practical option, and we see that as having a real possibility in the railway of the future.
Helen, sorry, I promised I'd have a question for you as well. I was just wondering about the hydrogen train, the hybrid hydrogen train. What kind of technology readiness level is that at? Is it something that's available to us now?
Helen, I think that's yours.
Yes. So we do have a hydrogen train, so it's a very high technology readiness level. We now want to go and do some longer term testing. Last year was all about getting the train to COP, which was the right thing for the industry to showcase that. Now it's all about getting some mileage and proving all of those systems and really building that robustness into that and being confident that we can go out and operate this as a train and passenger service. So yes, very high readiness level, but the last stage is really for the railways to get a reliable train service and performance on something that's very new and different.
There are hydrogen trains in passenger service in Europe.
Yeah.
On the Buxtehude branch in Germany, there's a hydrogen service. So the technology readiness level is there right now.
Yeah. Brilliant. Any other audience questions?
Hi there. I'm on the financing side, and one of the things that we often look at is the expected working life of the assets. So thinking specifically about sustainability and carbon emissions that side, what's your view on how your estimation of working lives will change? I guess I think the obvious thing to say is that technology becomes obsolete, it might be replaced by newer technology, therefore working lives could get shorter. But then the flip side, like you mentioned, is that new assets require so much carbon to produce them that it might be the other way. We might sweat our assets longer to reduce the full life kind of emissions. So any thoughts on those kind of topics?
So my view is that the technologies we're talking about are very durable. So if we're investing in overhead line catenary, overhead line catenary that was installed 70 years ago is still in service. So these investments last for the long term, and they are very durable. I see no reason why ammonia engines or battery trains or hydrogen trains wouldn't have the service life of today's trains. So I think we can make good investment cases with a payback over a number of years, and I think we can make a financial case based on assets that are really, really quite durable.
But I think that gets more a diesel asset today that's 10 or 15 years old, are you thinking that because it's going to be supplanted by an ammonia train or a hydrogen train in 5 years, that's not going to have the useful working life that perhaps you thought, when it was created? That's more the angle.
I don't think that's a major issue at this stage. So if you look at the legal deadlines for decarbonising, 2050 for England, 2045 for Scotland, those dates give us enough warning that if we've got an effective plan, we can manage our assets so that we achieve those deadlines, but we don't throw things away. But some of the deadlines are on us right now. So to electrify, the whole network, we need to be starting the schemes soon. and really ramping that up. And then for some of the commitments we've made for things like electric vehicles, those deadlines are on us absolutely now. So Network Rail, we have a commitment that by 2027, we won't have any electric cars and vans. So we won't have any diesel cars and vans. All our fleet will be electric. Now, of course, we're on a 4 to 5 year lease cycle. And that means that to achieve 2027, that means that every vehicle that we need to be buying needs to be with that in mind right now. So we've got to phase out buying of diesel vans right now in order to have an electric fleet by 2027. So,
then,
yeah.
Beg your pardon. Sorry, I didn't mean to interrupt you, Martin.
No, go.
But this is where I think, again, the point about retrofitting comes in, is that just because an asset may still be retrofitted, there may something, adjustments may happen to it. That doesn't mean that it's at the end of its useful life. So we know that some vehicles and some different assets obviously go on to have new lives in new and fantastic ways we couldn't possibly imagine now. But then also David's point about recycling batteries, even though technically some things are becoming obsolete, they're not fully obsolete, if that makes sense. So we don't need to completely throw the baby out with the bathwater, to use a bit of a trite expression. If you agree with me, David.
I do, yeah.
Brilliant. Any other audience questions? Got a gentleman at the back.
John Hammond from Precast Advanced Track. I don't know whether many of you know, but there is a section of track paid for by the Innovate UK here at Long Marston. It's 50 metres long, made of low carbon concrete, there's no steel in it, made from precast units. It was installed by McCulloch Rail way back here in 2017. It's passed the testing done by ACON with the RTST, but the important factors now, 6 years later or 7 years later, is the environment. And if I told you that we've actually recycled ballast in situ on that track, so there's nothing was taken away, nothing was brought back, recycled the ballast completely in situ, that was done at 100 metres a day. The new technology will do 1 kilometre a day. Secondly, no steel in the slab, but we've got new concrete from Norway, which eliminates basically any voiding in the slab, which is called tritonite. It actually makes the concrete double the strength. So instead of 120-year design life, 50 Newton concrete, it's going to be 100 Newton concrete. You can work out how long that's going to last. It'll be like the blue bricks on railway bridges. They're indefinite life. So we built the concrete, we built the foundation. Now with McCulloch Rail equipment, we can install the track with 3 slabs together, guess what, at 1 kilometre a day on a single track. No lifting over the adjacent track. So what have we got to do between now and 2050? What's your plans to do to actually deballast the track? Stick in PCAT. We cost £2 million a mile. You've got 20,000 miles to install. That's 800 miles a year. We can do it with the present teams of people renewing railways. And actually, by 2050, we'd save you £1 billion. But after 2050, we'll save you £7 billion per mile on maintenance of railways. We have the technology. We've submitted a bid to Innovate UK for smart grants and also for first of a kind. But really, we do need a partner that's got the guts and the where and the site to actually push the technology. People say, yes, but. Southampton University like it, Birmingham University like it. In fact, people in India like it. But we need somebody that's got the ability to do that. And this is what's lacking in this country at the moment, is foresight. We can't wait for more and more railways to be washed away. What happened in Norfolk? The sea overtopped, didn't it? And actually washed the railway away. And the driver spotted it. Actually, that could have been a disaster. And there's lots of those around the country. So I'm not trying to make a public address here about our technology. It's about trying to get funding for that. So hopefully, okay, thank you.
No, absolutely. And actually it leads perfectly into a question that I was about to ask anyway. So thank you for setting me up so nicely. How can other companies work with your organisations? You know, we work in some situations in rail, are very siloed. Rail is a challenging industry to break into. How can other organisations of all sizes, from startups through to SMEs, through to even larger organisations, what are the steps for getting involved with your respective organisations?
Do you want to go first? Or?
Well, for Network Rail, I think that for new technology, our research and development programme provides lots of opportunities to get involved and get and to win funding for railway developments. So Alison Smith, Ali Smith is the contact. She heads up our research and development programme, and she'd be really interested to hear from people who've got good ideas, who are looking for investment in new technology on the railway. For existing products, then I would say our national technical heads for whatever the asset discipline is, get in touch with them, people like Gareth Evans for track, James Dzimba for signalling. If you get in touch with them, make sure they're aware of the product, then they can look at how we specify that for future schemes and make sure that it gets deployed across the nation.
Brilliant. Thank you. Clear answer with names. Couldn't really ask for more, could you?
So for Porterbrook, we already work with quite a lot of suppliers, SMEs, on lots of projects. So we had over 30 companies, and including a large number of UK SMEs working on the Hydroflex project. So that is already happening. So we've got an active procurement team who introduce people and make sure that you can get in touch. And we've got an innovation pipeline project for tracking kind of ideas and how we might help work with suppliers and partner with suppliers to get their products into rail.
Brilliant. Fantastic. Thank you.
Well, at my colour, we were slightly different. Obviously, we are probably still an SME, but I think we punch well above our weight. I'd say we've been part of that process as well. And I mentioned earlier about Unipart Rail. So the company's been going 30 years, and for 29 years it's been quite entrepreneurially based, and now it's on a more formal business footing. So we're only now starting to look at the sort of funding that's available. Generally, it's been self-funded by us, but we are getting a increasing number of contacts externally. We've got a design team and a manufacturing team within the business as well, and that's proving quite popular. So anyone that has ideas, it's quite a very good avenue to go through to get those assessed and put into reality. But it's quite an exciting part of the journey. But I think you said we're only now really accessing the proper funding to enable that to happen. It's been self-funded up to now, and that probably has slowed growth.
Yeah, that makes sense, and especially the last couple of years as well. But I think the main message here is the door's open. There are definitely people in each organisation, different sizes, of course, but very eager to have those conversations and to get the best innovations, I would say, out of the people in this room and this field. Are there any other questions from the audience before we close? No? Wonderful. Oh, we do have another question. You waited until the very last second there.
Hiya. So clearly, decarbonisation of the railway is going to be quite costly, and I assume there's funding set aside for that. Is there an equal amount of money being set aside for the biodiversity crisis, or is that being treated? Is it receiving less money?
So this relative scale here. So electrifying the whole of the national network with Catena electrification is a £50 billion project. So that is of a different scale to the biodiversity work. The biodiversity work is funded. We're putting more money into it than ever before. We're spending more in the next control period, assuming that we get the settlement that we've bid for, than we are in this control period. We're using the technology that I mentioned. We've done a whole load of pilot work in Kent, where we did about 60 trial sites to see how we can get the best value for money. So we are using new technology, we're using new methods, we're investing more money than we have before. But honestly and fairly, the cost of electrifying the whole national network is of a different order of cost, and you'd understand that.
Yeah, absolutely. Wonderful. Any other questions before we close? We've got a gentleman over here.
Thanks. Sorry, I'm Christopher Moulton. Been around rail for too long, probably. All the things people are talking about decarbonisation, all they're doing is getting rid of fossil fuels, possibly, and making, so in other words, they're being less bad than fossil fuels. Nobody is doing, we've just built the world's first biomethane-powered tram, and that is actually doing good for the environment. That's not just not fossil fuels, it has no climate change whatsoever, and we can't get any feedback from DFT or anybody. We got a small amount of money to design it from Innovate UK. So all the things that are happening won't stop climate change. The only way you're going to stop climate change is by capturing the methane, and nobody's looking at that, and I can't understand why.
Did you hear the answer to the question about companies getting involved with these organisations?
I did indeed,
Just
yes.
So I would say, if the panel's happy for me to answer for you, that definitely get in touch, because it certainly sounds interesting to me. So please do get in touch with our three representatives here through the avenues that they've identified. But does anyone want to come back specifically on the topic?
No, I think that you've covered that, Daisy. But Department of Transport are also really engaged with this.
No, they're not. They do not understand that using biomethane causes no climate change whatsoever, and they say there's not going to be enough biomethane. We've got stuff all around the world. I mean, there's 22 million gas vehicles around the world, but the Department for Transport are set on zero emissions at the point of use, which frankly is a nonsense expression.
I'm finding that the conversations I'm having with the Chief Scientific Advisor and people, they are genuine. They don't have all the answers yet. I don't think anybody does. But I'm finding that they're really up for the conversation, and that I think what I would advise is that you contact the relevant people, for rail, like Dan Moore and people like that, and start the conversation, because whilst they haven't got all the funding in place, that's a fact. They haven't got all the answers, but nor have we. They are really up for the conversation, and if people are bringing new technology solutions, I think they're up for the discussions. And we're finding it really interesting, and we're starting to find some answers. But it's not fully funded. We're not fully there yet, but we've got some interesting technologies, and we've got a client who's genuinely interested in working with us to solve the problem.
Brilliant. Thank you. And you just got in again. Go.
It's just very quickly. You mentioned battery, hydrogen, ammonia. For those branch lines where electrification's not viable, if you had a crystal ball looking 20, 25 years in the future, where would you put your mortgage? Which one do you think would be the future? Or is it too early? Too early to tell?
I think it is too early to give you the absolute breakdown. There is no doubt that catenary electrification will be most of it. So catenary electrification will be all the main lines. You just can't beat it environmentally, and it's cost efficient for busy lines. So there'll be some boundaries with rural and secondary lines where some of these alternative fuels come into play. Quite where those boundaries are and where they'll be, I couldn't tell you. Battery is extending its range, but there's likely to be a worldwide shortage of lithium in years to come, so I think that will be a factor. Hydrogen also expanding its range, but it occupies a lot of space on a train. So again, all the work that Helen and team are doing to make this more practical will play into the arguments. But for us, the really big tricky factor is rail freight, because at the moment batteries and hydrogen don't have the power density to pull a 1,000-ton freight train. So for us, the really difficult issue is if freight runs on a line, then it probably needs electrification with today's technology. And that's why we're really interested in ammonia, because the ability to create a truly carbon-free fuel that has the power density to power a freight train, that's of real interest to us, because that might save us electrifying some lines which currently carry freight. So I've probably not answered your question precisely, but those are some of the things that are going into the mix.
That's really helpful. That's really, really helpful.
Wonderful. Well, All that remains to do then is to thank our speakers again, and especially to thank our sponsor in McCulloch, and to wish you all a wonderful rest of your afternoon, and hopefully see many of you, if not all of you, again tomorrow. So a big round of applause, please, for our speakers.